so today we're going to start Chapter 7. Chapter 7 is called Systems of Equations. What do you hear when you hear systems of equations? Two equations, right? You hear plural, right? So we're going to be dealing with more than one equation. And what we're going to learn is how to find the solution. This chapter is all the same lesson, but taught different ways. So how do you find it? By graphing. How do you find it? By substitution. How do you find it? By elimination. There's many, many methods to find a solution to a system of equations. And each day we're going to learn a new method to how to find the answer. And then whenever you're given it in real life, then you can decide which way is best for you. Okay? So right here, this is a normal system of equation. Do you see two lines? Yes. When two lines intersect, the point of intersection is the solution. So right here, that is your solution. That's how most answers will look. It will just be two lines that intersect, and the answer is found where they intersect. This is where, this point is not only the solution, it is also called where x satisfies, or x and y, so you can put x and y, satisfies both equations. Meaning, that's where their x and y are the exact same. Do y'all see that? They share that coordinate where x and y are the exact same for both equations. So where x and y satisfy both equations. Now, when it looks like this, you will only have one answer, one solution, an x, comma, y. Now, look at the next graph and tell me about it. What kind of lines are these? These are parallel lines. Are they going to have a solution? A point where they meet? They're not. So anytime you have parallel lines, the answer is going to be no solution. So you can either write the words no solution, or you can draw a circle with a line through it, meaning no solution. Remember that parallel lines have the same slope. So these will have the same slope. Now, in this last one, there are two lines graphed on this picture. But what can you tell me about them?
They're the same line.
They're the same line. So they graphed it, and then the next one fell right on top of it. These are the same line. What's going to happen is it's going to be infinite solutions, or you're going to put all real numbers. Meaning every point that falls on the line is a solution to both equations because they ended up being the same line. These will have the same slope and the same y-intercept. Same slope, same y-intercept. Now again, today, going into this chapter, we're going to be doing the same thing every single day. We're going to be finding that answer. But every day, I'm going to teach you a different method to find the answer. Today, we're going to look at it by graphing. Now, graphing only works when the answer is an integer, like +1, +3. If there's decimals involved, graphing's not your best choice because you won't have an accurate answer. Make sense? Today's all of our answers will be integers, okay? So let's look at the first problem. How many equations are you going to be given? 2, because we're going to graph a system of equations, and where they meet is going to be the answer. Now, you have to decide how you want to graph it. I personally would put it in y equals mx plus b form, put the y-intercept in rise over run. So the first thing I need to do is what to this equation? Rearrange it. So I'm going to bring this 2x to the right by subtraction. So I have y equals negative 2x plus 6. You can then either use your y equals button. Does everybody remember how to use your y equals button to graph? And I'm perfectly fine with that. Or you could just say, look, it has a y-intercept of 6. So I go here 0, 1, 2, 3, 4, 5, 6. and I would go rise over run, down 2, right 1. Again, if you're struggling with that, just use your y equals button, which I will show you just to remind y'all once my calculator turns on. If you go to y equals and you type in negative 2x plus 6, and then you go to the table second graph, it'll give you a list of coordinates to put down. Okay, but I'm going to do the y-intercept is 6, and then I'm going to go down 2, right 1. And you want to put as many dots on here as you can because you are looking for where they intersect. Okay, and then I'm going to connect my dots. All right, now I'm going to go do the next equation. What do I need to do to this one? Rearrange it. All right, so if I rearrange it, I'm going to pull the 2x to the right by subtraction. I'm going to be left with negative y equals negative 2x minus 2. I cannot have a negative y, so I have to get rid of it by dividing by negative 1. Yes? So everything gets divided by negative 1. And it becomes y equals 2x plus 2. All right, again, you can either use your calculator and put it in your y equals button, or you can go to the y-intercept at 2, put a dot, and my rise over run is positive 2 over 1, so up to right 1. Do you already see the intersection? So I don't need to put a ton of dots on this one because this is your solution right here. This point right here is the solution. But I'm going to go ahead and connect my line. And then I'm going to write my solution as a coordinate, an ordered pair. So where am I at on the x-axis? Positive 1. Where am I at on the y-axis? Positive 4. So my solution is positive 1, positive 4. Super easy. All right, let's go do the next one. All right, the first equation is y equals negative 2. Do y'all remember how to graph that? It's a straight line that passes through the y-axis at negative 2. So I go to the y-axis at negative 2, and it's a straight line that passes through that point. Okay, so now I'm going to go graph the next equation, but the first thing I'm going to have to do is rearrange it. So I'm going to get rid of the 3x by subtraction. I'm left with negative y equals negative 3x minus 1. You can't have a negative y, so you divide everything by negative 1, which makes everything opposite. So y equals 3x plus 1. So my y-intercept is at positive 1, so I put a dot. I'm going to rise up 3, right 1, but that's not going to take me to this line, is it? So instead of going up and right, which way could I go? Down and left. So down 3, 1, 2, 3, left 1, and I see the coordinate and the solution right there. And I go ahead and make my graph because I am going to be grading the graph, so make sure you're connecting both lines even if you see the solution. So this point right here is the answer. So where am I at on the x-axis? Negative 1. Where am I at on the y-axis? Negative 2. All right, let's do like 3 more and then you can get your assignment. All right, looking at this one, how do you graph an equation that says x equals 2? Go to the x-axis to 2, and it's going to be a straight line that passes through the x-axis at 2. Okay, to graph this equation, what do I need to do to it? Rearrange. How do I pull this 2x to the right? Subtract. So I have y equals negative 2x plus 1. So my y-intercept is going to be at positive 1, which is here. I can either go up to left 1 or down to right 1. Which way is going to take me to the other line? Down to right 1. So down 2, 1, 2, right 1. And I'm going to do it again. Down 2, 1, 2, right 1. Do you see your intersection? Right here. And then again, you write your answer as an ordered pair if there is a solution. This is the solution, so where am I at on the x-axis? Positive 2. Where am I at on the y-axis? Negative 3. And that is the solution that satisfies both equations. All right, let's go do this one. The first thing I need to do is rearrange. So how would I get this x to the other side? So I have y equals negative, I'm going to put a 1 in front of it since I'm graphing, 1x plus 3. All right, so I'm going to go to the y-axis to 3. And then I'm going to go down 1, right 1, or up 1, left 1. Okay, so there's my first line. Okay, and now I'm going to go graph the other one, but the first thing I need to do is rearrange it. To get this x to the other side, I'm going to subtract. So I have y equals negative 1x minus 3. What do you see right away with their slopes? They're the same. Are the y-intercepts the same? No. So these are going to be what kind of lines? They're going to be parallel, but let's go graph it and see. I have a y-intercept at negative 3. And then I'm going to go down 1, right 1, or up 1, left 1. Since these are parallel lines, there is no ordered pair that will ever satisfy both equations. So the answer is no solution. You can either write the words no solution, or you can draw a circle with a line through it. Now, if you forget the line through it, you're telling me that the solution is 0 and it's wrong. Okay, so you have to make it look like that. All right, let's do one more, and then I will give you your assignment. So let's go do this one. All right, first thing I need to do is rearrange the equation by moving the 2x by subtraction. So I have a negative y equals negative 2x minus 3. Whenever I have a negative y, it turns everything opposite, yes? So I have y equals 2x plus 3. So I'm going to go to the y-axis to 3. And I'm going to go up to right 1 or down to left 1. Okay, now I'm going to do the next equation. The first thing I need to do is move the 4x to the right by subtraction. So I have negative 2x equals, negative 2y equals negative 4x minus 6. I'm going to divide everything by negative 2. So I'm left with y equals 2x plus 3. What do y'all see right away? They are the exact same equation. So if I go here and go up to right 1, it's all identical. Notice every single point is going to satisfy both equations. Yes? So the answer is all real numbers or infinite solutions. Okay, if you look at 1 through 6, it says tell whether the ordered pair is a solution of the linear equation. So your answer will be yes or no. In order to tell, you're going to have to plug it in to both equations. In order for your answer to be yes, it has to satisfy both equations. So it would have to be yes, yes. If you get one no, then the answer is no. So let's do number 1. You're going to plug in 0 for x and negative 4 for y. So I would say, is 0 plus negative 4 equal to negative 4? Yes or no? So this one's yes. That does not mean my answer's yes. The ordered pair has to satisfy both equations. So I'm going to try the second one. Is 0 minus 5 times negative 4 equal to positive 20? Yes, it is. So since both of them have check marks, my answer is yes. So do y'all understand that if you get one no, you can stop and just put no? Make sense? Okay, on 7 through 12, it wants you to match the linear system with its graph. I will do one with you just to show you my strategy. Okay, the first thing I would do is rearrange them to y equals mx plus b. So look at number 7. To rearrange this, I would pull the x to the right by subtraction. Yes? So I would have negative y equals negative x plus 2. And what's that going to do since it's a negative y? It's going to make everything the opposite. So I'm going to have y equals positive 1x minus 2. Okay, and then I'm going to do this one as well. To move this one, I have y equals negative 1x plus 5. Now, the way that I would do this is just look at the slope and the y-intercept. So on this first equation, where's the y-intercept? At negative 2. So look at A. Is there any line with a y-intercept of negative 2? Nope, so it's not A. Go to B. Does this equation have a y-intercept of negative 2? Yes. Does everybody see it right here? And then what's my rise over run for this equation? So I go up 1, right 1. Is that good? Up 1, right 1. So this one's good. Now I'm going to go check this one. Is the y-intercept at 5? Yes. Is it going down 1, right 1? So the answer to 7 is B. And I'm going to put it right there and then mark it out. So do y'all see how to do that one? Same thing for 13. Oh, not same thing. This one's even easier. For 13 through 15, it says, use the graph to solve the system. Do you even need to graph it, or did they already do it for you? So look at number 13. Where is your answer? Right there. So all you have to do is write the coordinate for that answer. Where am I at on the x-axis? I'm at positive 2. Where am I at on the y-axis? And that's it. Don't worry about it. It's already graphed for you, so don't go do anything extra. Okay, go to the back. On 16 through 21, you are going to have to graph them and write your answer. So just to show y'all, here's my answer key. I need to see, just glance, the graph with the coordinate. Everybody understand? I'm not going to do one with you because that's what we did on our assignment. On our notes. So you're going to go graph both of these. I expect to see every single thing. I want to see the graph with 2 lines where everything's connected. Use your straight edge. And then I want to see your answer. So it'll be 2 questions, the graph and the solution. Make sense? And then you're going to do number 22, and then you don't have to do 23. Don't overthink 22. What are we learning? The solution is where the lines. Do you see where the lines meet right here? And that's probably going to be your answer. But you're going to have to interpret it. Look at the x-axis. What does it say? Here since 1990. So you're going to have to write the year and then the answer on the y-axis of whatever that is. Okay? All right, you may start.